All right. Hopefully you guys can hear me. Welcome, and I apologize if you're watching this and you were in class Monday. Some of this stuff is going to be the exact same to start, but if you weren't, and I try to get you guys to come visit me in Zoom, but I know it's early in the morning, so here's a video. So 4.3 and 4.4, 4.5 are kind of all go together. 4.3 deals with all 6 pieces of information. So if we can, of 2 triangles, so we're trying to start, or we are starting, proving 2 triangles are congruent to each other. So 2 triangles are congruent to each other if all the sides are congruent and all the angles. So in these drawings, you can see that angle A goes with angle D, E to B, and C to F, or yeah, C and F are congruent to each other. And then the side lengths in between those, so like DE is congruent to AB. So we need to understand how to label 2 triangles are congruent to each other. So these 2 triangles are congruent, but it's more importantly how you label it. So as we said, angle A goes with angle D. So when we label those 2 should go together. And then it doesn't matter what order you put the first triangle in. So like I said, we could do triangle cab for the first one. Well, wherever A would go, D would have to go with it. And same thing with B and E, and then C and F. So if I did do triangle cab for the first triangle, well then when I put my second triangle congruent, then I'd have to start with F, because F would have to go with C, and then it would have to go D because it goes with A, and then E goes with B. So it'd have to go FDE if I did triangle cab. So order of that matters, and we'll get a little more practice at that a little bit later when I try to help you guys out with some worksheets. I know that's why some of you guys are probably watching this right now. And when we see this, we want to understand that triangles can move around. Transformations, this is just translation. They can move, slide one way or the other. It can rotate, and then it can also flip, which I can't do that on the screen here, but it can flip around. So we want to be able to see how one triangle becomes the other triangle, okay? And I'm going to go to this screen, keep my view up. Somehow that paused there. So, and so here, if you guys remember problem stats and flipping 3 coins, you get a choice of heads, 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 tails, heads, tails, heads. Remember kind of your sample size? Well, then we're kind of doing the same thing. Is we're going to try to get down to just knowing 3 pieces of information. So instead of knowing all 6 pieces of a triangle, so can we know between the sides and the angles? So that's what all these S and A's stand for, is sides and angles. So we could start with knowing all 3 sides. So side, side, side is how you'd read the first one. Second would be side, side, angle, side, angle, side, and so forth. Okay? Well, some of these work and some of these don't work. On Monday in class, we talked about if everyone thought of an equilateral triangle, all the angles would be the same. So if we look at the bottom one, angle, angle, angle. Well, if I had you guys all draw out an equilateral triangle, all your angles would be 60 degrees. I mean, yeah, if we're drawing it, it might be off a little bit, but we understand that we meant them to be 60 degrees. We get that. But there's no way that every single person in the room's triangles would be the exact same. They'd all be congruent to each other, because we don't know what size, we don't know what the length of the sides are. So therefore, our triangles are all going to be similar to each other, because angle, angle, angle is a good way to prove similarity, because if we know 2 angles, we know a third angle, but it doesn't prove congruency. So which ones work and which ones don't, that's going to be more this problem like this. So you guys notice, I'm sure you guys were laughing at the ASS, but that doesn't work. Believe me, I tried. But we have a video in your Schoology that has 3 different videos on it, and the last one actually points out why those 3 won't work. So we can kind of get rid of those 3, and then what we're going to do is we're going to switch to the worksheet. And if you see your worksheet looks like this is the one we want. And I'm going to go through a couple of those problems here real quick. All right. So you notice I copied over the 5 3 pieces of information that works. And there's really not 5, there's really just 4. Because these two, notice, are just opposites of each other, and it really doesn't matter what order you put them in. So really I think there's just 4 pieces of information. And what we have to keep straight. So we have side, 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 angle, side. Now some of you are like, well, there's an ASS. That could be. No, this is a little different because the angle is actually between the two sides. As same as down here, the side is between the two angles. So that's what's different between these two here, these two groups. Angle, angle, side is their 2 angles, and then the third side, or the third piece of information, is a side outside of those 2 angles. So it's just the side coming from one of the angles and not the side between the 2 angles. So let's get to going on this first one. Now, in Monday in class, we did this one, so I apologize. You might want to fast forward through those if you already have this done. But we have side is congruent to this side. Now, I would encourage you not to put an S here. I'll show you why. I'm going to put an S here for right now. And then you have this side here is congruent to this side up here. Well, the reason I don't want you to put an S over here is a lot of people think, oh, I have side, side, side right now. But this side is actually part of this triangle and not of this triangle. You need 3 pieces of one triangle to be congruent to 3 pieces of another triangle. So we don't really want to do this. We just want to understand that, hey, if I have this side over here, it goes with this side there. So that's one piece of information. I have this side is congruent to this side. So there's 2 pieces of information. Now the third piece of information, a lot of people would say, oh, angle A goes with angle C. Well, it looks like it. They look like they're both 90-degree angles, but remember we talked about we can't assume things in geometry. We don't want to assume that. We can't assume a measurement of an angle. So unless that's told to us or somehow we could prove it, we can't use that as our third piece of information. So we look at real closely, and we look at both of these triangles, see how they're laying on top of each other, and they're actually sharing this side BD. And since BD is the same length for both triangles, we could say BD is congruent to itself, and we call that reflexive property. And that actually becomes our third piece of information. So these 3 sides are congruent to these 3 sides. So therefore we can use side, side, side of a way we can say the 2 triangles are congruent to each other. I made fun of myself last video. I just stopped recording this, and I still can't draw correctly with my mouse. And then we have to make sure we put these triangles in the right order, and this is why I messed up last time when I did this, so this is take 2. Good thing I do videos. But triangle AB, well, let's start with angle A. And sure, we'll go angle AB, and then I gotta remember to write D this time since I wrote C, because I guess I'm used to singing the alphabet. ABD is congruent to what triangle? Well, we know angle A goes with angle C. I think you guys can all see that. So if I start with A here, I'd have to start with C here. But notice now I went from A to B, which is kind of the short length. So if I start at C, I have to go down here to D, which is the short length. So that's where the sides come important in the angles. So you have to go triangle CD and then B. So I want to make sure, you know, that B and D are the same angle, which this angle here is an alternate interior angle for there. Well, we think we don't know that for sure because we weren't told these 2 lines are parallel. But now that we have congruent triangles, we go on for that, but that's a whole nother thing. So anyway, side, side, side is a way to do that first one. I'm going to skip number 2. We'll come back to it maybe another video. I'm going to jump to number 3 because number 3 has multiple ways of looking at it. Okay, right away, hopefully you see that this side is congruent to this side over here. So that gives us a side. Okay. Now, we don't know any other side lengths, so we're probably done with the sides. But notice that this line is also parallel. Remember, these arrows mean that the sides are parallel to each other, or the lines are parallel to each other. So if we remember in chapter 3, remember a transversal. So if this is a line, and this is a straight line, I know it looks kind of offline here in the middle, but we're going to assume that it's a straight line. And I know we talked about no assumption, but remember, we can assume a line is a straight line. So this angle P down here is actually congruent to angle R up here. Because remember, alternate interior angles from chapter 3? Well, that's at alternate interior angles, so we know they're congruent because if the lines are parallel to each other, the alternate interior angles are congruent to each other. Okay? Well, we could do the same thing for S and Q too. So if we did that, we get an angle. Oh, goodness. Let's start over. Come on, hand. Don't drop me now. Okay, we have an angle. And then we'd have this side. And then we'd have angle S down here. So that would actually give us an angle, side angle. So you guys could actually put that over here of why the two triangles are congruent. And you could mark that S is congruent to Q. And that's a way. I want to point out another way. So there's actually two ways you can do this problem. And there's multiple ways because it depends on which angles you actually use. But remember vertical angles? So these two angles in here are vertical angles to each other. So if I was doing this as a proof, I'd say angle STR is congruent to angle PTQ because of vertical angles. All right, but this is actually going to give me a side, an angle, and then another angle. And some people wonder, well, how do you label this? Well, if you started here and you went angle, side angle, and you wrote down angle, angle, side angle, in this case, this would not be right because I don't know the side between the two angles. You know, where over here I used it because that's when we were talking about this angle down here. If we knew that angle, we were going to use that angle congruent to angle Q. So that'd be angle, side angle. But if I'm using these, I would have to say it's side angle, angle, or angle, angle, side. It doesn't matter which way you go with that. It means the exact same thing. Okay? Now, which triangle is congruent to which triangle? Well, angle or triangle QPT, let's say, is congruent to which triangle? Well, a lot of people would say R because we start with Q on the top. But remember, Q goes with S because of alternate interior angles, even though we might not use that in this one. But R goes with P, so we got to put S with Q, and then R with P, and then T goes with T. So that's how you do those, and that's kind of what we're looking for. So I'll try to come up with videos on how to do those other ones too. Okay, so hopefully things are good. Make sure you guys send me emails with questions, and I'll keep coming with some videos if that helps you guys out, or let me know what I can do to help you. All right, talk to you later. Bye.